and welcome to General Physics 1. If you're not supposed to be in General Physics 1, feel free to chill and back late in the morning. I'm not sure you're anywhere else to be. Right, so I am Cecil, and your station instructors will be either me, Dr. Narayan, Dr. Daniel, or Dr. Wall. Presumably, through the course of the semester, we will see you in recitations and get to know you better. You will see me every Monday morning and Wednesday morning at 8 in the morning right here, hopefully. Okay, before we get to any real physics, a little bit about us. This is the physics department, you know, and that handsome devil right there is me, and I have hair. And most of you guys are exercise physiology, biology, various pre-health fields. There will be some of you from other majors, which is totally cool. Physics is the science of the physical world. It's our understanding of the physical world. And nowadays, at least, most research, most work you do when you get out of college in your degree will be in some way, shape, or form interdisciplinary, which means you're going to have to at least be conversant with the language of physics along with the language of your major. And that's part of what this course needs to do, apart from very kidding about the math. Okay, so the idea here, my research area, of course, is biomedical imaging. I look more at cancer tissue. That's when I started out. You guys probably need to remember metal detectors at airports, but you need to know. The idea here was to look through clothing, and you basically do that using light. Light of various frequencies. Different materials are transparent to it, and different materials reflect. So the idea here was that skin, normal human skin, reflects a certain frequency of light, while clothing is transparent. Right? So using terahertz imaging for that at least, you're able to see an object that's concealed behind my t-shirt. Right? It's not an action card, it's just a metal object shaped like that. They didn't give me that. But it's not just metal, right? I mean, the idea is why not metal detect. If you want to look through clothing, you can also see any plastics, right? Which wouldn't show up on the net. The same technology, of course, can also be used for cancer detection. Right? It's basically how cancerous tissue responds to different frequencies of light. And that's what you're using to try and tell what's cancerous and what's not cancerous. Right? A little bit more about the physics department. We are sitting right next to the nuclear reactor, which is that big cylindrical building right down there, I believe. My geography is okay. Right? It's over there. It's perfectly safe. You can get towards it if you want. It's kind of fun. Other people in the department also work on cancer cell detection, new cancer therapies, essentially nanoparticles used in cancer treatment. We have a pretty strong medical physics program. There's also a photonics center which makes small devices. There's a space science and technology center that actually does send stuff into space. They do run projects with undergraduate students of various disciplines. The reason being, you want various disciplines, right? I mean, yes, there's a lot of physics involved with sending stuff into space, but what do you want to see in space? Right? Are you interested in the chemistry of different stuff out there in different knowledge? Right? There's a lot of physics as a tool in a lot of ways, right? Used in a lot of sciences. Okay. Right. Now let's get to a little bit more important stuff, semantics. Course logistics. You guys have access to Blackboard. Blackboard is going to be your go-to for all course information. Okay? A few requirements. You're going to have a bunch of homework. It's going to be fun. And presumably, it will make you better grades. Two basic types of homework. Written homework and online homework. You guys are required to get Sapling Plus. Okay? And the first time you sign up for Sapling Plus has to be via the link in your Blackboard course. Okay? Do not go directly the Sapling Plus access comes with an e-text, which it's free, it's required. You can get the paper copy of the textbook if you want from the bookstore or elsewhere. Either which way, you will have the e-text. The second homework is, by the way, the online homework will come to you once a week. There is no homework this week, right? This week you basically have time to get into Sapling and make sure your Sapling account is linked. Right? You do have a free lecture, but I don't have. The second form of homework is written homework. Right? And written homework is due in recitation. You will get a week to do like 3 or 4 problems, which will be assigned on Blackboard. Right? So your first written homework will become available next week, and it's due the following week in your recitations. Everyone with me so far? Okay. And 3 lecture assignments. 3 lecture assignments are in Sapling. They're basically a bunch of videos, 15 minutes or so, over the weekend with a little bit of coffee, if that's what you prefer to drink. Watch the videos. What I say in class will make more sense, presumably after you watch the videos. Okay? A lot of physics, we're going to be dumping a lot of physics actually. You guys are basically doing a 2-semester survey, 1 or 2 semester survey, depending on your requirements, of an entire field that people have been working on for centuries. Okay, so you're going to get a lot of information thrown at you. Right? The more times you see it, the better you will become at it. Right? So pre-lecture, you see the material first, you see it again in lecture, and then you go to recitation and you see how to work with it. Does that make sense? Okay, your first pre-lecture assignment is due on Monday. Right? It will become available after lecture today. And you have till Monday to watch a series of videos. If you haven't had time to get Sapling Plus, the code from the bookstore yet, don't worry, you can still go to the link in Blackboard, click the link, and you have a 2-week free subscription to Sapling. Right? So within that 2-week period, you have to get that code. Okay? For the lectures, you can bring a calculator if you like. I'm okay with you guys using your phone. And you guys will need a wireless device, which is your phone or a laptop or an iPad, basically something that connects to the internet wirelessly. Okay? I'll get to why in a minute. Labs. This is important. There are no labs this week. Labs start next week. Okay? That's the general physics labs. And that's Razvan. He's your course TA. Right? So if you can't find me, find him. You are looking for someone to blame and run over in a parking lot, good substitute for me. Okay. My office is in the basement, which is actually this floor, somewhere over there, like a hint away. Actually not that hard to find. You have a bunch of resources available for you to get help. Right? This is getting help with homework, concepts that you didn't understand. I encourage you guys to work in groups and homework if that's what you prefer. Right? There's no issue in working in groups. The Sapling homeworks, the numbers are changed, right? But we're not bothered with the final numbers, so to speak. It's more the method that you want to learn. Right? So work in groups. Talk to your recitation instructors. Talk to me. Come find me in my office. If not at those times, shoot me an email. Like remember, if you guys aren't there telling me about your physics problems, I'm sitting there making physics problems. So, probably better if you come by. There will also be physics tutors available free of charge in only 136, probably somewhere after the end of next week, once the TA schedules get finalized. There's also tutoring available in South Africa. Okay? My point here is there's a lot of resources available. Right? And none of these resources are supposed to do your homework for you. Right? They're supposed to help you do your homework. So try and do it. If you have further questions, come find out. Right? If there's anything that you guys are confused about, come talk to us. Right? I expect you guys to go to 2 lectures and 2 recitations a week, and more than that, put in 6 to 10 hours every week to study this. Okay? And a lot of study physics is practice. Right. The reason I need you guys to bring your cell phones or your laptops to class, not that if I said don't, you would stop. It's a good reason to check your text, right? But we're going to be using iClicker Read instead of the actual clicker device. This course is participating in higher program, which means available to you. Okay. What you need to do is get an iClicker account. And again, in order to do this, you have to go from Blackboard. Right? The first time you sign up for iClicker has to be via the link in your Blackboard account, which is something like that. So when you click into your Blackboard account, you should see an iClicker sync link right there. Okay? That will take you to iClicker. That's where you make an account. And again, that takes you to lectures. And that's how we'll be doing participation in lectures, which is 10% of it. Right? That's attendance. And as an FYI, it is wireless, so it's Wi-Fi, but it is geofenced. So it can't be from the dorm room, it has to be from within this room. Okay? Right, that's not all on the iClicker, there's more. So once you do that, it'll create your account. Your institution is UMass Lowell. You will see my class in there, and once you have your, it'll give you a 2-week free trial for free, okay, like when you sign up. Sometime within these 2 weeks, you have to actually go into all, into your settings and enter a subscription code. Okay, that subscription code is this guy. Okay, that's your free access code. Don't worry about writing it down right now. As an FYI, all the slides for the lecture are posted in that. Right, including this. Okay, your lecture slides will become available to you the day of the lecture, starting at 7:30 a.m. that day. That day's lecture will be there. Okay, and then they'll stay available until the rest of the through the end of the semester. The fun stuff about using iClicker, and remember it's a pilot program, which means you're learning and I'm learning. But part of the cool things is we use it for attendance, but all your clicker questions, all my clicker questions, are going to end up being flashcards available for you for study, right? For exams, tests, quizzes, etc. So fiddle around in iClicker, right? The nice thing about iClicker is it will tell you if you're actually signed into the session. So if you have an issue and you're in class and it's telling you you're not signed in, file it on class. Right? Okay, so that's the clicker requirement. Now let's get to a little bit of physics. Okay, we focus on conceptual understanding of physics. Okay, there is math. Math is the language of physics. We're going to stick to algebra, trig, and geometry. And this week in recitation is going to be practical. Basically math. I don't know where your last math class was. But it will come back. It's probably like writing that, right? Once you know it, hopefully it stays in the back of your head somewhere. Anyway, don't let the math bog you down, right? A lot of times people get more stressed about the math and they miss the concepts, right? Physics is, at least right now, about understanding the physical world around you, conceptually first, and then putting that concept into math, right? This course is not designed to see if you can solve for application. Okay, that's not my interest. My interest is figuring out if you know when it's for application. Right? It's getting to that point. Like taking a given physical situation and putting it in the language of physics, which is math. And that is a lot harder than it sounds. Okay? It takes practice. It takes an understanding of the concepts that you want to consider and how to put those concepts into an equation. Because physics is, at the bottom line, it's about quantifying what you see. Right? It's not just about understanding how stuff works, it's about understanding how much that stuff works. We need numbers. Okay? So there is a fair amount of quantitative analysis and problem solving in the course. The setup is, in physics we start with generalizations, right? There is a connection between the moon revolving around the earth revolving around the sun, the third step. As in, you take a complex situation, identify a simpler underlying form, which basically means you identify the overarching concept, right? And you use that concept to solve that problem. Okay? So the broader field of physics, which we won't cover in one semester, but in 2 semesters you can kind of get a feel for it. This semester we'll be focusing largely on mechanics and fluids, right? Mostly mechanics. Which means that at least for the first part of the semester, a lot of the examples are going to be about how awesome a driver I really am. But more than that, first couple of weeks we're going to have a bunch of math, right? The math you see in the first couple of weeks is math you will see throughout the semester. It doesn't get significantly harder in terms of math. Okay? So I know I'm telling you it's not a math course, and at the same time I'm telling you it's going to be 2 weeks of math. Okay? Trust me, both statements are true. Okay? So mechanics is where we'll start, and a lot of mechanics, the first part of it is stuff you guys have probably seen. It's the physics where you have a bunch of equations, you have a word problem, you're identifying what's what, and substituting. Right? Hopefully we'll be done with that within the first week and a half. Right? And then we can go into understanding why. Right? The reason that's still important is because that is your basis for quantifying stuff. Right? That's how you actually quantify it. After you learn how to quantify it, we can go into understanding why. Okay? The other topics are really more second semester stuff. Okay, American units. I said American units, not SI units or SI units. All the units you will be using in this class. But these are the units that you are presumably familiar with. Time measured in seconds, minutes, hours, days. Weight measured in pounds. Length measured in feet. And temperature in Fahrenheit. I personally have never used temperature in Fahrenheit. These are the units I want you to know. These are your SI or your standard units, which is what you will be using in physics. Time is measured in seconds. That stays the same. The SI unit of mass is a kilogram. Right? A lot of people think it's gram for some reason because it's the only SI unit that actually has units. But the SI unit for mass is a kilogram. Okay? And the SI unit for length is meters, not kilometers. The SI unit for temperature is Kelvin, which no one in the world actually uses except physicists. Like for example, your doctor doesn't tell you your room temperature is 300 Kelvin. Right? I mean, if they said you're at 300 degrees, you'd be worried. Okay, how do we define these units? So the idea here is when you're talking about scientists from one community talking to scientists in another community, you have to have certain standards. Right? I can't just say my foot is the standard for that. Right? It might be my personal standard for that, but unless I'm willing to chop it off and ship it to like Australia, it's not going to work. Right? Plus it might change. I might still be growing. So we define most physical units in terms of physical constants. Right? Length, the meter, is defined in terms of the distance traveled by light in vacuum in a certain time frame. Time itself is defined in terms of the number of oscillations. This is the periodic motion, which is repetitive, infinitely repetitive. The number of oscillations of a particular atom. Right? Time, like a second, is specifically defined as that because if you measure that anywhere in the universe, it's the same. Okay? Mass, the last one, is actually the only standard still defined by something physical as opposed to a physical constant. Right? It's defined by the mass of a platinum iridium cylinder, generally kept in France, and there are copies of this distributed all over the world. The US copy is kept by NIST, and you get standards like this guy. Right? This is obviously not the same guy, but it's measured against it, and within a certain reasonable accuracy, it's around the same. Like it's around 80. Okay? There are efforts underway to redefine mass in terms of physical constants. Right? The nice thing about defining stuff in terms of physical constants is it's the same everywhere in the universe. You don't have to compare it to an actual physical standard. Right? Okay. Enough chit chat, let's get to math. Converting units. So, physical quantities almost always have a unit. Right? And one of the things I want you guys to remember is if you're adding or subtracting two physical quantities, they must have the exact same unit. Right? I can add the number 2 to the number 3 and get the number 5. Great. Right? But I cannot add 2 seconds to 3 kilograms. That makes no physical sense whatsoever. Does that make sense? Right? So, whatever you're adding and subtracting has to have the exact same unit. Right? They actually have to be the exact same unit, as one has to be meters, the other one better be meters. Right? Not centimeters, in which case if you convert centimeters to meters or vice versa. Right? The same unit. This is not true of multiplication and division. You can divide a physical quantity which has a certain unit by another physical quantity that has a different unit. Like I can divide it by time and I get meters per second. Right? Which is a unit for another physical quantity, velocity or speed. Okay, so you can derive units, but when it comes to addition and subtraction, the quantities concerned must have the exact same unit. Okay, the way you convert units is essentially multiplying it by 1. When you multiply something by 1, you don't change it. Right? That's the idea of multiplicative identity. Right? So you have conversion factors. Like for example, over here you have 1 minute is 60 seconds, right? So you can say 1 minute is equal to 60 seconds, right? So you can rewrite 1 as 1 minute over 60 seconds or 60 seconds over 1 minute, right? If you're converting from seconds to minutes, right, then the unit you want cancelling out is seconds, right? So seconds is in the numerator, seconds should also be the denominator of your conversion, right? So that's all that happens here. Okay, it's just a process of multiplying by 1. So let's do a quick example. There we go. Okay, so you have 3.3 days. And I want this in minutes. Right? So your first step, of course, is do you know the conversion factor? If you know the conversion factor, we're going from days to minutes. Most people know days to hours, hours to minutes. Right? So your conversion factors are 1 day is 24 hours and 1 hour is 60 minutes. Everyone with me? Okay, so the first unit I want to cancel is days. Right? So this number, 3.3 days, multiplied by 24 hours over 1 day. Right? This is where you put the day in the units. And this is 1 because of this. Does that make sense? That ratio, 24 hours divided by 1 day is 1. Right? Because of that conversion factor right there. Okay? So that will cancel the days, and that will give me the number of hours in 3.3 days, but I'm looking for minutes. Right? So, again, I'm trying to cancel hours, so it's 60 minutes to 1 hour. And this guy is true as 1 because of that. Everyone with me so far? So we end up with a number. Can someone tell me what that number is? What? Minutes? Great. Okay, we'll get to a little bit more about that number in a minute. No pun intended. The idea here is I've taken a certain physical quantity, which is 3.3 days, right?
multiplied it by 1 a couple of times, so I have the exact same physical quantity, right? I just have it in a different unit system, right? Changing the unit system does not change the nature of the quantity. It is still a measure of time. Okay, I didn't suddenly convert 3.3 days to kilograms. That's not going to happen. Everyone with me so far? Okay. We'll come back to that number in a minute. Let's go back and discuss prefixes for a quick second. Right. So the main prefixes you're going to use this semester are like centi, milli, kilo. So centi is 10 to the minus 2, right? Centimeter is 10 to the minus 2 meters. A centigram is 10 to the minus 2 grams, right? A milligram is 10 to the minus 3 grams. Millimeter is 10 to the minus 3 meters. So that prefix, milli, is 10 to the minus 3. Right? Other common prefixes are kilo, which is 10 to the plus 3, like 1,000. Right? Mega, which is 10 to the plus 6. Micro is a very common prefix. A micro is how much? Nanosecond minus 10. What's micro? 10 to the minus 6, right? It's a common prefix because it's approximately the size of the cell. Right? It's 1 micron is approximately the size of the cell. Okay? Okay. Now let's do a slightly more convoluted unit conversion. So this is, I'm going to try and leave the conversion factors up and see if I can get both. Nope, that's the DocGam. Okay, we're just going to write down the units and go from there. I can do this. We may be stuck. Okay, I'm going to tell you the question. It is to convert 65 miles per hour to meters per second. Right? Notice it is still the same unit, right, in terms of physical quantities. Now we're talking about converting speeds, right? I'm going to give you a couple of conversion factors, which is that 1 foot is 12 inches and 1 inch is 2.54 centimeters. There are 100 centimeters to a meter, and I expect you guys to know that. Okay? Right, so start converting while I figure this out. Yes, okay. So, my first step here, of course, is 65 miles per hour, so the hour is in the denominator, right? Let's convert the distance portion first, right? The way we do a convoluted unit is one step at a time, right? We convert the miles to meters, and we convert the hours to seconds, right? But we do it so that, we're canceling appropriately. So, I know that I want, I gave you the wrong conversion units. 1 mile is the one you want, which is 1.609 kilometers. Okay, that's the one you want to use, unless you know the miles to inches conversion. You'll get the same answer regardless. Okay, so I know that 1 mile is 1.609 kilometers. I know that miles has to be in the denominator in order for it to cancel. Right, so I'm left with 1.609 kilometers over 1 mile. Right? The unit I'm looking for length is meters. Right? So I need to go from kilometers to meters. Can anyone tell me what that conversion is? 1,000, right? 1,000 meters is 1 kilometer. Don't mix them up the other way. Okay? 1,000 kilometers Okay, so convert the kilometers, so that's 1 kilometer times 1,000 meters. And when I do that multiplication, that will give me the meters portion, right? But now I still have this hour, right? If you look at the units cancelling, right? The miles cancel, the kilometers cancel. So the units of this quantity, right? 65,000 is 65,000 meters per hour, right? I need to get that to meters per second. So I need to go from hours to seconds, right? So I know that there are 60 minutes in an hour and 60 seconds in a minute. So that's 3,600 seconds in an hour, right? So 1 hour over 3,600 seconds. Notice that over here, that conversion factor, the hour has to go in the numerator because it has to cancel an hour in the denominator. Okay? Right, and when you do that, that should give you an answer in meters per second. Does anyone have a number for me? 2.91. Sorry? 2.91. We're right there. 29 is the one I got? Okay. So it's 29.05 or something meters per second. I haven't memorized it. I did just do it before. No memorization. Okay. Except of course what the prefixes stand for. I do expect you guys to know what those prefixes are. Right? Kilo stands for 3, milli stands for -3, micro stands for -6, and so on. Okay. So that's how you do like a convoluted unit. One more unit type. And that is a square unit. So, what do I measure in square units? Areas, right? What do I measure in cubic meters? Volumes, right? And the reason for this is dimension, right? An area is a length times a length, correct? So it's a meter times a meter. So the SI unit of area is a meter squared. Okay, the SI unit of volume is cubic, right, or meters cubed. Can I subtract an area from a volume? No, right? The units have to be exactly the same. I cannot subtract or add meter squared to meter cubed, right? But I can divide one by that. Does that make sense? Right? So if I knew the total volume of this room and I knew the area of the floor, I can divide that total volume by the area to get the height. Right? But I can't subtract it. This making sense? Bringing some bells from geometry, right? Whenever that was. Okay. Right. Converting those units. So we're looking to convert 1,000 square feet to the SI unit, which is square meters. The conversion units for this question are the ones I gave you by mistake in the last one, which is that 1 foot is 12 inches and 1 inch is 2.54 centimeters. Okay. Right. So the number we have is that, right? It's 1,000 square feet, right? I can get rid of one of the feet by multiplying 12 inches over 1 foot, right? That cancels exactly one of these feet. If I did this, right, the units of this number are 1,000 times, so 12,000 feet inches. Okay, that is not inch squared. It's nowhere close to meter squared. Okay, so we need to do it again. You need to cancel that second foot up there, right? So it's 12 inches is 1 foot. If this was 1,000 cubic feet, I would have to do it again, right? Multiply it by the same factor again to get rid of the third foot up there. This making sense? Right? So you have to cancel all the unwanted units. After that, you go with inches to centimeters. So I have 2.54 centimeters is 1 inch, right? But I have 2 inches in the numerator, like an inch times an inch in the numerator. So I need to have an inch times an inch in the denominator. This makes sense? Right? I need to cancel all the unwanted units. And of course, that's not all. I need to keep going. 2.54. So this answer is in centimeters squared right now. Right? I need to get it into SI units, which is square meters, which is, it's 100 centimeters to a meter. So it's 0.01 meters is 1 centimeter. Right, and does someone have a number for me? Something like that? Perfect. Is this making sense to everyone? Okay, you're going to be doing a bunch of unit conversions, and this is kind of just part of the problem. Right? When you see this problem, right, as you will later on throughout the rest of the semester, make sure you work in a slightly square. So your first step is conversion. Right? Convert everything to the appropriate SI unit. Okay? Now, the next part is we're going to look at all this math all over again in terms of significant figures. Okay, significant figures is nothing but a measure of how accurate your measurement is. Right? When I say a certain number is that number, it doesn't mean it is that number with an arbitrary degree value. Right? Significant figures can be fun. Trust me. Like, I like to give my height in meters. In meters, my height is approximately 2 meters. Okay? It sounds a lot better than whatever the number I come up with in the okay? If you convert 2 meters to feet and inches, you might definitely know where those 6 feet or anything so. But it is a question of precision, right? It's like, I'm like 175 centimeters. So if I round that to one significant figure, right, that's 2 meters. Right? 1.75 meters to one significant rounds to 2 meters. Right? But what this is telling you is there's a certain precision associated with every single number. Okay? And the number of significant figures is an indication of how significant and how precise your measurement actually is. Right? So, for example, the second one over there, 1200 seconds, right? Depending on what you measure, right, those last 2 zeros are essentially placeholders. Right? They're just telling you that this number, the actual measurement, is somewhere between 1100 and 1300 seconds. Right? That's why I rounded to 12. Okay? Like 11775, right? Would round to 1200 if I were to do it. But the reason the sig figs and the reason sig figs are important is when you're doing all these conversions, you can suddenly end up with a lot more significant figures than your measurement actually had. Right? Like for example, the very last problem that we did, this conversion. Right? How many significant figures did my actual measurement have? Only that one significant one, right? The preceding zeros are just big. How many sig figs is my final answer? 3. Is that possible? Is it possible to take a measurement and just convert it to a different unit system and take my measurement back? No, because the instrument, like, the precision of the measurement is set by the instrument you use to take it. Right? One last thing is scientific notation, and this is going to be relevant halfway through the semester when you start dealing with really, really big numbers. When you put stuff in SIs, you can get a whole number of numbers, and you begin with a number like 384421000, and put the comma to the right place, and then you forget a zero, which is stressed about the exam. It's not very good. Right? And it matters in physics because those zeros are always matter. Right? So a lot of times we use scientific notation. The idea with scientific notation is you have a preceding part, which is all the significant figures in your number. Right? So when I write that down in scientific notation, I have 3.84421, which is all the sig figs in that measure. Correct? Times the power of 10 in order of magnitude. Everyone with me? Right? So scientific notation is just a way to write numbers not just more compactly, but also to indicate the precision of it. The number of significant figures in that. That makes sense? And rounding in scientific notation is again very significant, right? At this point, you just round it. Okay? Great. So, your homework for today is make sure you go into Blackboard, sign up for Sapling via the link in Blackboard. Make sure you go back into Blackboard, sign up for iTaker via the link in Blackboard, go to recitations, practice math, come find me in my office with any questions, go introduce yourself to your recitation instructor, move into your office and see me on Monday. Hi.
I signed up for iTaker, and I don't know if there's anything I need to do on my end. There's no recorded absences here.
You have any recorded absences?
I don't know why.
I'll check that. You fine.
Alright, cool.
You signed in?
Yeah, I did it.
Perfect.
And also, do I have to go through the bookstore to buy the sapling, or can I just do it
No, you
online?
can do it online. It's just cheaper through the bookstore, I
Really?
believe, especially if you want, I don't know if you're doing a 1 semester or a 2 semester sequence.
I think so.
Yeah, so I think if you're doing the 2 semester sequence, check the sapling, but I'm pretty sure the bookstore has a very good one.
Really? For just
the
the
same
online
thing.
code?
Yeah, it's the online code and it comes with the ebook.
Thank you.
I just wanted to properly introduce myself to our math students. My name is Quantitative Analysis, and I wanted to know, are your office hours like already posted on Blackboard?
No, I put them in the lecture. They'll be in Blackboard probably by the end of the week, but don't bear just the office hours in mind. Just shoot me an email and come find me. Hi.
I had a question regarding your emails. I just wanted to ask about the labs. Does the lab next week, are there one lab like every 2 weeks?
Yes, it's one lab, your lab section. I don't know whether you're meeting next week or the following week.
So the odd numbers meet next week?
That's on Blackboard. I
I'll
don't know.
double check.
Yeah.
Also, I have a question. So our exam will be doing Wednesday, Saturday,
No.
lecture, so 8 a.m.
The schedule's on Blackboard. You 3 mid-semester exams. I think they're all on Wednesdays. The dates are already up.
What is the format of the exam? Do you do any specific response?
No, there's a third of the exam is multiple choice. 2/3 of the exam is short problems, long problems. Again, it's in the syllabus. So the course policy statement outlines what's in the exams.
Also, would you do a study guides? Not study guides, practice exams for the exams? No.
I do not have these exams. But we give worksheets. The clicker questions will be posted in the sense the slides are posted.
Are they similar to the exam questions?
They're similar to the concept questions.
Alright.
And there'll be worksheets in recitation. And then you get homework. So the exam is always drawn from stuff that's
So we
covered.
already went through. Okay, thank you.
Right.
Okay, so the two things you said we had to work on was the sapling and the clicker, right?
Yes.
So the sapling, is that what's in the bookstore?
You can get sapling from the books. It's the access code. So Sapling Plus is an online homework platform. So you have to sign up for it via Blackboard. But when you sign up for it, you need a subscription code, which is what you can purchase in the bookstore, or you can purchase it online. It's just cheaper in the bookstore.
Do you know how much that usually is, or does it change?
I think it depends on whether you're using the 1 semester or the 2 semester sequence. I think my understanding is the 2 semester sequence is $99
Okay, and that's the
for both semesters, including the book. I think a single semester might be 65 or 70, but I don't know the exact numbers. The bookstore does.
And then the eye clicker,
Yes.
is that also?
That's free, but you have to go via Blackboard.
Okay.
So go via Blackboard, click in, the subscription code is in the lecture slides for this.
Okay.
Right? Gotten emails, I haven't looked at them yet. Anything I need to know about? For the exam. Yeah, so lecture recordings are posted, lecture slides are posted, so Echo is where the lecture recordings are, it's again in Blackboard. Lecture slides are posted. If you need extra time on quizzes, or your recitation instructors, if you need, they'll have gotten the notification anyways. And exams, we should talk before the exam because I think you have to fill up or something. Yeah, it's like it has to be sent somewhere, right? Yeah. You're allowed to have to a certain extent, yes. You get a little more practice. I'll give you the equations and the equation sheet. There's an equation sheet with the exams. There's no memorization of equations. Okay.
Hi. We're both student athletes, and so we're on the cross country team, so we just I hate it. And this is our schedule. Yeah.
Perfect.
Just in case.
The main ones are the exams. You guys are planning to miss an exam.
Yeah, I'll make sure to let you know anyway. Thanks so much.
Hi, I'm
Hi.
Angelina.
Hi.
I'm Highlands.
And I'm Carol. We're on the women's hockey team, and we don't have our forms right now.
That's fine.
Thank you.
Thank you.